All right, welcome back. So today we'll be discussing chapter number three. Chapter number three actually has two parts to it. The first part we'll learn about how to customize and format our data, and there's a specific library we'll be learning about. And the second part is how to read the input from a file. In the first couple of chapters, we read the data in the project number one and project two, data from the user. Today, we'll learn how to read or write the data to the file. So let's go ahead and get started. So you will see that there are a few things which we already have covered, especially about C in and C out by using IOStream library. So we'll be exploring another library today as well to use some of the additional functions. And we'll be dealing with string data, some of the other logical errors as well. All right. Let me make this one smaller. Okay. So this part we already have covered. We have some understanding that input output is a sequence of bytes, streams of data, which comes from the buffer area. So for example, if you're reading from a user might provide you some data via keyboard or some other snipping tool or something other method, but data can come from a sensor, data come from a database, from a file. There are various sources for the data input. Um, the data, so if you remember in the first chapter, we read that data, each character is stored in a byte, and that's what the data comes. And then we have to also have to know that if we are capturing the data as a whole number, as a decimal value, as a single character, as a Boolean value, or as a textual data. So based on that one, we need to have appropriate variables in place. So if we are picking up the data, we have to use an IOStream library from the user. Especially we have something called CIN, which is one of the objects in IOStream library. And in fact, in this slide, it shows that IOStream library can have additional streams called for IOStream for input file stream or output file stream. And so C in belongs to iStream and C out belongs to OStream. And we have been using those for last couple of in the last couple of chapters. And this is the library we have been using. And for sake of understanding, that's all you need to include in your program. You don't have to specifically include these additional objects because they are built into IOStream library. And you can read a variable value at one at a time or multiple values. I recommended last week that you just read one piece of data at a time, although this is also fine, variable one, variable two, and you can read multiple values at the same time as well. So nothing is significantly new so far, and it's just additional information providing no difference between a single CIN with multiple variables. And I recommend you just read a single piece of data at a time and during the learning processes. And once you actually have developed more experience, then you can read multiple pieces of data as well. So char is allowed you, it allows you to basically read one character at a time, and int allows you to read a whole number. And we saw in the second chapter that it could be plus minus build 2 billion or so values. So it's a pretty large number. And we decided to stick to integers. We are not going to use short or long integer. Similarly, we decided to stick to double instead of float or long double. Double is going to take care of all of our needs we have. All right. So again, nothing is new so far. So don't worry once you're reading the material. Don't feel overwhelmed. It's the same kind of discussion we had in the first and second chapter, and we have been using C out and C in the last couple of projects as well. All right. Then it shows something we already have done. For example, if you have declared CH as a character, it can only pick one character at a time, and characters are indicated in single quotes. If you have a value like AB, it can only pick up A, and B is sitting in the buffer. B is not read but it is sitting in a buffer. Now, if a variable a is an integer, so 48 will be picked up successfully. But if you give a value like 48.35, sorry, 46.35, then because it can only handle the whole numbers, 46 will be picked up and 0.35 is held for the later input. Okay, I'm going to move forward. And here you can read multiple pieces of data, which I do not recommend, but you have the ability to do so. It's giving you some additional demonstrations. All right, so this is where the chapter really begins explaining some of the additional functions. And if you remember in the second chapter, we also talked about a function. Function is basically a subprogram which has some certain statements. So far, what we have been doing, we have been using a function called main function, which is where the compiler basically starts executing the code. We have not developed our own functions yet. We'll be developing our own functions much later. Today we'll be learning about some pre-existing functions or predefined functions. These are the functions not developed by us, they're developed by somebody else. We'll be using these functions from existing libraries. So that's what it's going to refer here. Other functions execute only when they are called. So these functions, when we need, for example, for precision purposes, for width purposes, or for power purposes, various mathematical functions or other functions, when we need to use them, we include that appropriate library and we can call those functions. Call basically means I'm going to give you some data and apply some functionality on that particular data. And so C++ libraries include many, many of these functions. And these are called predefined functions. They're organized based on those libraries. Okay, so header file may contain several functions. To use a predefined function, you need the name of the appropriate header file. So you have to know the name of the function. That's very important. Now, some functions do not take any arguments. Some functions, they take arguments. Arguments mean, or parameter means, what data I'm going to pass when I call that function. So then the function knows I'm going to capture that argument or that parameter, and I'm going to do something with that one. For example, if there's a square root function, if you pass 9 to square root function, it's going to return something back to you that is called the return value. In that case, it will be 3. All right, so here's a POW function. And again, this function belongs in CMath library. So you have to use number sign, include CMath library, and then you can use this POW function. POW function requires 2 arguments, argument 1 and argument 2. These arguments are separated by comma. So if you say 2 here and 3 here, just like over here, power 2 comma 3, it means 2 to the power 3. So the answer will be 8 in that case. So this power function, if you ever want to use it, you must include CMath library. And then there's another function called get function. The get function inputs next character, including white spaces. Now, cin by itself doesn't have the ability to read white spaces. White spaces are basically the terminator for piece of data. What if you want to read any kind of character, including white space? So then you have to use something called get function. So it stores in a memory location indicated by its argument. And this is where the data will be stored, whatever the individual character is read. All right, and we'll be using these in our demonstration. Sometimes you want to ignore garbage data. So we have a function called ignore, and ignore allows you to, and we'll see that ignore has 2 arguments, and there might be some example here, right there. So here we are saying ignore 100 characters. And if you find the enter key in the process, you can stop ignoring. Let's say after ignoring 3 characters, there's an enter key, then you don't have to continue to ignore. So this allows you to clear a lot of garbage. So for example, you're expecting some garbage data, you can start ignoring those garbage characters. The putback function places previous character extracted by the get function from an input stream back to the stream. So for example, if you use the get function, which we saw in a couple of slides earlier, and that is not in the buffer area, but if you don't need that character anymore, you can put it back. There's another very useful function called peek function. Peek function returns the next character from the stream or from the buffer, but it does not remove the character from the stream. So character is still sitting in the buffer or in the stream, but you are not really removing it. You're just looking at it. You're just trying to identify where the character is. And this is how you can use put back function. This is the character you want to put it back in the stream. And this is how you can use the peek function. The peek function becomes very useful because sometimes you just want to peek just to see what kind of data is coming in. So on the basis of the data, you can make certain decisions. All right, so let's take a look in the statement here. Cin.get. Cin and get are two separate identifiers separated by a dot. Dot separates this input stream from variable name from the member or function name. If in C++, dot is the member access operator. We use the dot operator here very significantly, and whenever you want to call a function of certain libraries, you can use the dot member access operator or dot, and it allows you to use that function. And this is very frequently used with string functions as well. Now, sometimes you're expecting a number. Let's say you're expecting somebody's age and they give you characters. So in that case, your input stream goes to the failed state. When it goes to the failed state, your program basically crashes. And in that case, you want to anticipate if something goes to the failed state, you want to bring it back to the good state. So that's what it's referring here. So sometimes things can go wrong during the execution. If the input does not match corresponding variables, program may run into problems and it may crash. And for example, trying to read a letter into integer or double variable result in the input failure. In that case, you have input error or you have failed state. In case of failed state, the program crashes. So that's where we can use something called clear. So clear allows you to clear the bad state or failed state. And again, I'll be demonstrating this to you and I'll be showing you. And the clear allows you to basically brings your ability to bring it back to the good state so you can actually continue to read more data. Here it is, output and formatting. So you should be able to format the data the way you want to format the data. And we have a library called IOManup library. This IOManup library stands for input output manipulation. Once this library is added, then we can do a variety of things. And in fact, there are many functions. One of them is called set precision. I want two decimal places set precision, so I can call that function. And then there's something called fixed. Fixed allows you to show certain number of decimal places. So we will see a show point and fixed, and I'll be demonstrating both of those just in a bit. And they're pretty easy to use. So whenever you want to show, let's say, for example, 6 decimal places by default, you can use fixed. Now, there's another manipulator called scientific. Now, scientific shows the data, double data in a scientific format. We'll be using that in the following chapter, chapter number 4, where we'll be using a quadratic equation and we'll be using scientific manipulator. And this is how you can use show point or fixed. A show point forces to show the decimal point and trailing zeros. And we'll see how many zeros, extra zeros are shown with show point versus fixed. Okay. Set W is very useful. It gives you the width. If you say set W, and also this one belongs to IOManup library. So you must have IOManup library. That's what it's highlighting here. So it gives you the width of 5. So let's say the value for X is 25. So, but you have set aside 5 spaces to display this 25. And because the value of X can change, maybe next time it might be 1000. So based on the anticipated value, you can set certain width. In that way, you can have a perfect justification or the data is formatted very nicely. And again, I'll show you by using setW. We'll be using setW for project number 3 as well. Sometimes there's empty space. You can use the set fill to fill that empty space with the dots or certain other characters. You also have manipulators called left and right to manipulate or justify it on the left-hand side or the right-hand side. Um, and this is how you can use set fill. You can put a dot or number sign, and it's going to fill those extra spaces with that particular character. And left justifier and right justifier, will be demonstrating that just in a bit. This chapter is actually a brief chapter, so I'm going a little bit faster so we can spend more time on a project itself, demonstrating what we need to look at. So we have covered so far set precision function, and all of these belong to IManip library, set width function, set fill function. We'll be using how to do show point and fixed and left and right justification, all sorts of different manipulators so we can show our data in a certain way. Now, also Cin, if you remember, I stated in the beginning of the chapter that Cin feels that whenever there's a space, it's a terminator, it stops reading the data. What if you want to read full name? You want to read the full addresses, and they have spaces embedded. Then we have a function called getLine function. GetLine function reads the uh, entire text, including spaces as well. All right. And so there are three types of errors. Most of the time you will get, or you can anticipate to get those kind of errors. The first one is called syntax errors. That's a grammatical error, which we mentioned that in chapter 1 as well as in chapter 2. The second type of errors are called logical errors. The logical errors are not caught by the compiler because this is not a grammar error or a syntax error. This is an error in your computation. This is the error in your logic. So those are the harder to find, and that's why it is very highly recommended you test your program over and over again just to ensure logically the program is working as expected. The third type of error is not highlighted here. It is called a runtime error. Runtime error is not a syntax error or logical error, but something illegal happens during the execution and the program tend to crash at that time. So you want to, as a developer, you want to avoid all three types of errors and you want to test and test. The last thing which is discussed in the end of chapter number 3 is the file input and output. Now, for this particular case, we'll be using a library called fstream library. We'll be including fstream library. And in fact, I'm going to demonstrate this fstream library first. Then I'll go and talk about IManip library and all the related functions. I'll show you how to read the data from a file and how to produce the output file. All right. So we've finished the chapter. Let's see if we can go to the demonstration and I can show you. And so this is where project number 3 is resides, and I'll be opening up that one for you. And this is what it looks like. I'll come back to that one just in a bit, but let me go to the compiler. And here we learned today a couple of new libraries. So I'm going to include those libraries here. I just want to make sure you can see my screen. I want to exit and share again. Okay, so one of the library we talked about is called IManip library. So I'm going to include that library. Another library we talked about is CMath library. Let me include that library as well. And another library we talked about is fstream library. fstream. I'm going to start everything with fstream library first. fstream library stands for file stream, and it has two objects. One is called ifstream for input purposes, input file purposes, and one is called offstream. So if I want to read the data from an input file means the data is already stored. data already exists. So I want to read the data from that input file. In the first and second project, we learned how to read the data from a user. So if I want to read the data from another source, such as a file, the file, basically, you're very familiar with files. You have been storing files for a long time. You write an essay, you have an Excel spreadsheet, you have a picture, video, those are all called files. Here we are referring to the simple files. The simple files are called flat files. These flat files are standalone files, and the data is in very simple format. Most of the files, they have hidden characters, but the files we have, they only have limited hidden characters. So I'll be discussing those with you in a little bit more detail once I create a file. So in order to create a file object or file variable, I will say if stream in, this is the variable I created. You can call this variable anything you like. I like to call it in, you can call it f in if you like. And then I want to open that file. So you say in.open, in.open, and the name of the file. So this file does not exist. This file does not exist yet, but I'm assuming this file will exist. So let's call this file input.txt. Again, I have not created this file yet, and I'm going to show you how to create that file in an online compiler. By the way, the online compiler which I use is called onlinegdb.com. There are many of these similar online compilers, and you will have access to this particular link from our Canvas site as well. And if you're using this online GDB, so all of the demonstrations are done in online GDB compiler. But feel free to use a different one as well. They're very similar in their execution. All right, so this file, like I stated, if I run my code, it does not exist. There's no data in this file. The file does not exist. So in an online compiler, see this icon here, new file? Looks like a floppy diskette. So you can click this one and it's going to say, okay, what do you want to call that file? I want to call that file input.txt, exactly the what I showed in my code. So it takes you over here. Here's my program. And here's the input file. Right now, my input file is completely empty. Let's add some data to it. I want to add 12, 98, 75. Let's say 3 pieces of data. I come back here. Now I know this input file, input.txt file has some data in there. I'm going to read the data. So how do I read the data? I need to have a variable to read the data. Let's create a variable called number. And I want to pick up the data from that file. Now this time I'm not going to say cin because cin is designed to read the data from a user from the keyboard. That's not what I want. I want to read the data directly from the user, sorry, from the file. And in order to do that, I had already created in object or in variable, which is of this type, if stream type, and this belongs to fstream library. So the usage is very similar. If I say in greater number, it means I'm reading the first piece of data from the file. Let's just double check it. I want to immediately display it just to ensure that data was read. Do endl at the end. Let's run it. If we pick up the data, and we do pick up the data from this file right there, we picked up the data successfully. It means our program is working. Let's read on the code. And as you can see, I successfully picked up the data. The question is, how come I did not pick up the second piece of data and the third piece of data? Because my program has the ability to read only one piece of data. If I want to read all three of them, let me demonstrate that here. If you copy and paste, although this is not how we do it in a real world, but if I copy and paste 3 times, and if I run the code, it's going to pick all 3 pieces of data successfully. And as you can see, 12, 98, 75, and the data was picked up and it was displayed here successfully. Now, this is how you can read the data from an input file. How do I create the data in the output file? So for that one, you will say offstream. Offstream is for output file purposes. And again, you can create a variable of something called out, or you can call it any name you like, and then create that file. open, just like what we did earlier, and whatever file you want to call it. Let's call this one output.txt. Again, this file, this output.txt does not exist yet. You don't see it. I see input, but there's no output. So this will be created when we run the code. All right, so I want to immediately, as soon as I create a cout statement, I want to put out statement as well. So it's going to add this number to the output file as well. Let's do that one here as well. Remove the C and make it out. Let's do that one here as well. And what it's going to do, it's going to display the first input from the file, which is a number like size number 12. It will be picked up and displayed successfully. And then immediately after that, it will be added to the output file. This output file doesn't exist yet. All right, this doesn't exist. As soon as I run my code, this output file will be produced. Let's try it. And there you go. You can see the output file is created and the data is stored successfully. This data was picked up from this file, processed over here, and added into this file. So this is how easy it is that you can actually read the data and display the data in the file. Now what we are going to learn, what if the data I want to display is double data type? Double data type. Same, everything remains the same. I run the code, I have the same results, I have the same results here, no difference whatsoever. But I want to show two decimal places now. So assuming some of these data, they had one decimal place, this one had that many decimal places, this had no decimal places. If I run the code, and if I run the code this time, you will see this did not have any decimal places. This had one decimal place, although this particular one had 5 decimal places, but the program by default only displayed 4 decimal places. So that's where this library, imanoop library, will come in picture, and then you can customize the data. You can format the data you wanted. Let's actually agree, and also this will be required in project number 3. I want to have all of them in 2 decimal places. But before I do that, let me include something here, which was shown in the slideshow as well. Cout set. Let's do the fixed one first. Fixed. And if I run the code again, simply just use fixed with cout. Run the code again. And notice that now what fixed does, by default, it gives you 6 decimal places with all the data. You have fixed 6 decimal places. Let's do the show point instead of fixed. Show point, and rerun the code. And it gives you 4 decimal places. So show point gives you 4 decimal places, which is the default setting in this compiler as well. But I do not want 4 or 6 decimal places. I want exactly 2 decimal places. So I recommend on the top of your program, simply say set precision right here, set precision 2, and just have that statement one time. It has a fall through effect, which means all the data will have 2 decimal places. Let's test it out. And now you can see 12 did not have any decimal places. 2 decimal places have been now visible. And this actually had only 1 decimal place. Extra 0 has been displayed here. Now I want to show you something else now. What if this value was very large like this? And if I run my code again, watch what happens. This is not properly aligned because this value was so large. And if you look at your transaction receipts or your statements, the numbers are always right justified and values are left justified. So in this case, it doesn't look very nice. For example, let me also show you here. Let's say this number is the rate. And if I want to display that number with the rate, And for example, this particular second number was hours worked per week. And we'll take a look at that one. And let's say the um, let's say quantity, just for the sake of displaying purposes. Watch what happens with my data now. So now you can see this rate is nothing is properly justified. By default, everything is left justified by default. What I want to do is I want to follow the universal standards, which means all the characters, all the values which are all the names and labels, they're left justified, and all the numbers are right justified, they're properly aligned. In order to control that, that's where this IOManip library comes again, and we can use something called set W. So now we can actually control how the data should be displayed. So we can put set W here, set W, assuming it might take 15 spaces. And, and then I want to do left justification for the labels. And for the number, I want to do another set W, let's say for 10 spaces. And for this one, I want to do right justification. Okay. It might not make too much sense right now, but let's just hang on to it. And then we'll come back and modify again. Let me just copy this from here to my second cout as well. And from here to my number as well. Right, number as well. And then also I'm going to copy this one for the third number, which is quantity, and do the same thing for the number here as well. So you say, well, how do I know this? This will come with a little experience, but gradually you will build it. So again, it might not be perfect, but let's just run it and see what it looks like. All right, so you can see this label is perfectly left justified, and we have about 15 spaces here. And then we have about 10 spaces here. But because this label was so long and this number was so long, our justification did not work very well. So although the quantity is perfectly justified with the rate and quantity are perfectly right justified, but this particular label was too long. So let's make it smaller. Let's see if we make it smaller, if it works. Otherwise, we have to add additional width for that particular piece of data. And now you can see it is perfectly, beautifully aligned. All these are left justified and all these are right justified. They're perfectly aligned. That's exactly what we wanted. We just wanted everything, all justification. If you feel that you need more space here, let's make it 15 here and 15 here and 15 here. Let's run the code again. It might look a little bit better, as you can see now. Now, what if I want to fill these extra spaces with dots or some kind of other character? That's where the set fill comes in. So you can actually have a set fill. Set fill has a fall through effect, or you can actually do individually as well. But if you want to do set fill applicable to all of them, you can simply do one time. You can say set fill, single quote, because it only can accept characters, and dot. And, and that's it. We'll come back and customize further. And I think for project number 3, you have to customize a little bit more. But let's just run and see what change it makes. Now this time, take a look here. All the spaces are filled with dots now. If you don't like it, you can always remove it. Why I'm showing you this, because once we look at the project, and I think you can see the project, all these values will be filled with these dots over here, as you can see right there. Okay, so that's how you can use the set fill as well. It allows you to fill empty spaces with dots. Um, in addition to what else I need to show you, what if you want to read let me see if I can show you the second page. I think we covered you should be able to have two decimal places. What if I want to put dollar sign as well? So again, you have to play with it a little bit. Let me just show you. If I put a dollar sign by itself, it might not be exactly how we anticipated. But let's just put the dollar sign here. If I put a dollar sign here, and if I run the code, and let's run the code, and you can see the dollar sign right there. But it messed up some of the other things. So that's why you have to spend a little bit of time figuring that out, because now it's giving you 15 spaces for the dollar sign. That's why it's kind of messed up. So when it comes to that one, and once you actually have been working on the project 3 and read the instructions, then it will make a little bit more sense. Now for project number 3, let me go to project 3. I just want to make sure that it captures everything. And I do not want to. Okay, I want to capture. Hang on a second. Okay, all right. Okay, and share. And so your job is to open this handout. And this handout basically tells you this is what the handout looks like. You will be completing this project. You'll be reading a gross amount of, let's say, 3575 gross amount, and then you'll be calculating certain federal taxes, state taxes, and other kind of deductions. All the numbers should be right justified. All the non-numeric labels should be left justified, and your net pay should be 2356. Okay, so that justification is necessary. So you will be displaying results on the screen as well as in the output file. All right. That's it for today, and we'll come back and discuss chapter 4 later. Thank you. Bye bye.